Welcome to all. This is lecture 25 of part 1, the most important class for finding resultant. See, earlier we found resultant for concurrent force system. If you remember, where we found only magnitude and direction. Now we are going for coplanar force system. Here you have to find magnitude, direction and line of action. Everything one by one I will explain. You need not start wondering why it is that way all. See, first make a class. First write heading. I am not writing heading here. To find resultant, see, I am giving heading for you. To find resultant completely for a coplanar force system in general. In general means neither concurrent, it need not be concurrent, need not be parallel. In general, I already told earlier what is the meaning of general. First, further write. Completely, this is all I told earlier long back, not long back, earlier many times. Completely means magnitude, direction and line of action. Why line of action we are not bothered for concurrent, I explained for you. Okay, start now. Fresh. Procedure I will give simultaneously for you. When I tell procedure, you should write it. Here board I can't write procedure. Only the notes I will write. Remember, it will be around 15-20 pages. Why? Every concept I am explaining there. Okay, start. Question first. This is question 1. Question 1 dictated in the class. Dictated. The question. For the given coplanar force system, see here. Given coplanar force system, this is a sketch given in the question. See, this is the sketch given in question. For the given coplanar force system, find the resultant completely. That's all. Over. Now start solution. Solution. And parallelly, you write procedure. Those who want going through the class, you have to write procedure. That is, if you are depending only on the class, means procedure you have to prepare. Otherwise, read the question 10-15 times. Not read the question, sorry. Go through the class 10-15 times. Read the question 10-15 times, what you will get. Okay, now, I remove this one now, not required. First, do not see other things I wrote. I wrote something so that time is saved. First, write. First, what you have to do is, once again, copy the question. Once again, copy the question. There is a reason. Copy the question neatly. Write the question. Solution starts now. Solution. Once again, write. And remember, in case of coplanar force system, distances also counts. So, forces are in Newton. So, decide unit. Unit we are going to cover is force in Newton. Okay, agreed. If they give kilonewton, solve in kilonewton. That's all. Distance, see here, 450 mm, 360 mm, 195 mm, 110 mm. Oh, distance are given in millimeter. Therefore, Newton and millimeter. That is, force unit in Newton, distance unit in millimeter. When you prepare procedure, you are right. See the question and decide the unit. Then you can write the exam first question. That way, prepare the units. But one thing, observe the question. Newton, okay. Millimeter, millimeter, millimeter. Two couples are given. Make a note here. Make a small note. Make a small note. In the question, he has given two couples. One clockwise couple of 75 Newton meter, some distance given here. One anti-clockwise couple of 15 Newton meter he has given. First of all, still in the class, he has not told anything about it. It is not correct actually. Something which is not explained so far, considering earlier, is not correct procedure. But he is considering because when a coplanar force system comes later, So many times you get not only forces but also couples. And question 1, what he is solving is the master question. That is a critical question which will completely cover everything. See now how much I am explaining. See there. He is covering completely. Therefore, he want to include the couples here. Therefore, write those two couples given clockwise 75 Newton meter, anti-clockwise 15 Newton meter. It will be told little later, not too much time. As soon as the coplanar force system resultant is over, I will go to parallel force system. Immediately, I will tell you about couple. Therefore, if any doubt is there, you see, wait for some time, he will explain. So, but therefore, here I will tell. See, this is those because first time in the class came. So, what I am telling now, you have to believe. There's a clockwise couple of 75. Oh, see, Newton meter. Our units we decided Newton millimeter. Therefore, since you decided Newton and millimeter, this Newton is okay. Meter should be converted to millimeter. Otherwise, it is completely wrong solution. So, right here. Therefore, write somewhere here. 75 Newton meter couple, this couple, given couple is, see, Newton meter means it is not, see, when you put this way, I am used to it. It is not a minus. When you write Newton meter is multiplying. It is 75 Newton into meter. So what do you want now? We want 75. We want Newton to be Newton only, but meter we want millimeter. So to convert meter to millimeter, multiply by 10 to the power 3, or will become 75,000. All are knowing it, Newton millimeter. Now, when you write the sketch second time, do not write 75 Newton meter. In that place, write 75,000 Newton millimeter. Same way you write 15 Newton meter will become 15,000 Newton millimeter. 15,000 Newton millimeter. So this you write when you put second time sketch. 15,000 Newton millimeter. First you write the, see, first you have to write the original sketch. If you enter in the original sketch only, what will happen? Later you can't make out which is converted, etc. Therefore, first you write whatever question is given, copy. Then when you start a solution, then change it. Okay, now unit problem is over. Okay. The unit problem is taken here. Now, one by one. See, go to procedure sheet. Right. If inclined forces are given, better to resolve them into horizontal and vertical I'm telling procedure for you. Better resolve them into horizontal and vertical component or along x-axis and y-y. So therefore, consider reference axis x-axis and y-y. How? This is x-axis, this is y-y. Write it here. You write somewhere. Everybody knows it. Still better write. Okay, then further. In this question, he has not given. This is no. This is not in the procedure. This you write a side note. When you in the question you write. The procedure you wrote. If inclined forces are there, resolve into component. In the problem, when you solve this question, you write. In this question, he has not given inclined forces. He has given only horizontal vertical forces. But it looks like, oh, maybe there is an inclined force here. He only resolved. See, maybe there is an inclined force here. See? Inclined force may be there. Then you write, why he could have given inclined force? And then question would have been more better. Everything covered. No, reason is there. If I give inclined force, this all side note you are right. Inclined force. Then when you resolve into components, sin, cos, etc., decimals will come. 18.417, 99.868, 13.4675443, 13.46754675468. We have to round off. For some reason, this master question, he want perfect answer, round number answer, or 0.333, 0.667, or 1.81746. That way, he does not want it. Why means reason is there. This question I am explaining very thoroughly. I am clearing all the doubts. Therefore, that is why the question is a preset question. Preset means I have set the question so that you can make out later. Net horizontal becomes 400, net vertical becomes 300, resultant will become 500, for resultant alpha will come 36.87 degrees, sine will come 0.6, cos will come 0.8. I have taken care because I am completely avoiding decimal. I have to explain so many things. But when you solve a question later, this way round number will not come. See next question. Next question I am giving inclined forces. I am resolving. So first question, for some reason, he wants what? He wants the result to be round numbers as much as possible. So anyway, so what? Right, over. Now start. First, procedure sheet. Already told. You write once again. You have to find the magnitude, direction, and line of action. Do one thing. Line of action later. First find magnitude and direction for resultant. In the same way as that for concurrent force system. Therefore, in the class, I will not explain anything. If this is not clear, better not continue my class. Okay, start. That is, find sigma fx first with sign, then write the answer without sign, but in correct direction. Same way, find sigma fy first with sign, get the answer with sign, then write the result without sign. Okay. See, since it is the first question, I wrote once again. Actually, I need not write. I can only write sigma fx. Why? It is already told so many times earlier. Still, I am writing. Reason why? Because first question. Okay. Algebraic sum of components of all forces along x-axis, that is sigma fx equal to, see here. Anyway, plus 150 minus 100 plus 250 minus 700. If you come minus 400 Newton. Therefore, sigma fx equal to, no minus now, 400 Newton. I took right side calculation, negative came left side. Algebraic sum of components of all the forces along y axis is sigma fy. I will take upward positive. Plus 400 minus 140 plus 200 minus 160 is plus 300. Anyway, I want to check the answer once so that in case by chance wrong means later I can't correct it. Where the calculator I kept, I don't know. Somewhere I kept my calculator. I see it. Okay. Better verify. After recording everything, lastly by chance a mistake means I have to tell sorry, there is a mistake. I do not want it. Plus 250 minus 700 is minus 400. Correct. 400 minus 140 plus 200 minus 160 is plus 300. Correct. Okay. Over. So sigma fx, sigma fy came. Then the usual statement you write regarding resultant, red color, remember, let R be magnitude of resultant. Now resultant is, see, one more thing. I will tell you one thing. When you find out sigma fx and sigma fy, if sometime for both of them you get a numerical value. Yes, we got. Special note. Sometimes when you find sigma fx and sigma fy, one of them will come 0. Okay, no problem. Then if sigma fx is 0, resultant is purely vertical. Or if sigma fy is 0, resultant is purely horizontal. Therefore, in the procedure, when you find sigma fx and sigma fy, if we get numerical values either for both or for any one of them, then the resultant is a force. So therefore, now I am writing of the resultant force. See, Earlier, I wrote only resultant force. That's the force. Okay, now, there below. Sometimes what happens is when you find sigma fx and sigma fy, both will come 0. Rarely. Then do not in a hurry tell resultant is 0. No. Then the resultant need not be 0. If sigma fx and sigma fy both are coming 0, that means resultant force does not exist. Then there is every chance that in the procedure you are writing in a box you are writing, then there is every chance that resultant is in the form of a couple. Then what to do? He will tell procedure later. Or I will tell now only. Then find magnitude and direction of resultant couple. No line of action. How to find? He will explain it later. We will add in that procedure sheet later. Okay. Or do one thing. You leave one page gap here. Let him tell later when it happens. What procedure he gives at that time, you write here. Oh, well done. Let R be magnitude of resultant force and let alpha x be angle made by resultant force with the xx as shown. Now see, take any point. Now the most important statement I will tell you now. Most important statement you are right now. 1 minute. Okay. Sigma fx negative came. Okay. Or sigma fx is left side. Sigma fx, don't put minus now, is 300 Newton. 400, sorry. Okay. 400 Newton. Left side. Sigma fy plus we got upward. 300 Newton. Now, 100% resultant will come this way. This I should not explain. Right here. How to mark R and how to mark alpha, that all told in concurrent force system. Learn from there. Now you have R equal to square root of sigma fx square. See, I am writing everything, this question, plus sigma fy square equal to square root of 400 square, no minus sign, square plus 300 square equal to resultant will come 500 Newton. And one more required. See, this is your x, alpha x, and alpha x equal to tan inverse of sigma fy. 1000 times I told, when you find angle with x, tan alpha equal to opposite, vertical by horizontal. Thousands of time I told, fx equal to vertical is 300, horizontal is 400, equal to, I know it is 36 point. I know the answer because it's a standard answer. I write the more accuracy, 36.807 I think it is. Okay, let me check it. Shift tan inverse 0.75. 86.8699 degrees. 869 868 degrees, or if I make it 9, this will become 8. If I shift up to here, 36.8699, I can take the almost 36.87 degrees. Okay, 0.001 error is not a problem. But remember, when I calculate sine and cos later, I will use this calculation later. Some important verification is there. at the time of that verification, right, he will use the original value of 36.8698 or he will use the original display of 36.86989765 degrees. What? Some will ask, what verification? Yes, there is a very, very interesting verification. Some very powerful concepts are there. For those things, I will use this angle. Over. Now, right here, in the procedure sheet, mark sigma fx and mark sigma fy through any point. Through that point, mark resultant R and alpha in the same way as concurrent force system. But one doubt comes right there, procedure. In the concurrent force system, you know this point. See, through which point all the forces are passing, through that point resultant passes. Therefore, that point through which he is marking sigma fx and sigma fy is that point where where in the question all the forces are passing to that point, usually O. Okay. But this time he still has not named it because we do not know this point. So therefore, that point is an unknown point. Since that point is an unknown point, some name required for that point. He will use the name for that point as X, unknown. X. 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 X means unknown. Why? Because where? Which is the, see, it is a concurrent force system. How many times I told it? I wrote, since all the forces are passing to the point O, resultant also passes through O, you pass through. If it is a concurrent, question is over now. Question is over. Therefore, yes. So, one extra statement you are right. Let R be the magnitude of the resultant force and let alpha x and alpha y be the alpha y be the angle made by resultant force with the x-axis. Next, let line of action, okay, line of action of resultant force pass through a point X. See, this way, shining X. Very important, shining X. Shining X. Camera I check first. Sometime what happens, it goes below camera. No, crystal clear. That line of action of resultant force pass through a point X. So this X is unknown. Okay, over. Right. Now, make a note. First of all, again, waste of time. If it is a concurrent force system, question is over. Why? Because then it is not X. See, this X is, make a note, this X is not that X-axis X. Some name required, I call X. I can change the name also. Okay, let it usually unknown point, we call X. This X is, has nothing to do with the X-axis or Y-axis, right? Unknown point X. Okay, some will tell, suppose, leave it, let someone tell something. I am not bothered. Sometimes it happens. Someone told earlier, sir, can you take Y? You take whatever you want. X over. Now, resultant pass through a point X over. If it is concurrent force system, instead of X, what do you write? You write that point O, known point. Question is over. Need sketch, show the resultant. But now, here, still pending. Okay, now what happened now? I told magnitude over and direction over. Now, the last step, that is line of action of resultant. Okay, now I am going to rub everything this side. This I am not rubbing, and I take a screenshot of this one or in a paper right here now. Or I will, next time I will tell, remember sigma fx we got this way of 400, sigma fy we got up of 300. We took the point through which both are passing as a point x, and this resultant makes angle alpha x this way. The value is 36.87 degrees. Because I cannot write each and every time this one. This is already there. You take a screenshot or write in a paper. I will continue now. Start now. To locate line of action of resultant force. This is the first time you are doing. Very careful. Some note I have given here. In the procedure also it will come. To locate, see, you write, go to procedure sheet. You write, first you write. But I am writing here also to understanding. This is for this question. To locate line of action of resultant force, we need just one point which lies in line of action of resultant. Last class fully explained. Just one point. We already considered a point x through which the resultant passes. See, just now I told let the resultant pass through a point x. This x passes through which resultant passes. Therefore, locating line of action of resultant now is just locating that point x. Y means what I can tell. To locate line of action, you require one point which lies in the line of action of resultant. We already considered a point x through which resultant passes. So now your procedure of locating line of action of resultant is actually locating that point x. Okay. Now note, there are infinite points in line of action of resultant. This x is just one among them. This you have to write in the procedure sheet and also write in the problem. In the notes, I will write it at least 2 pages. Okay, over. Now, continue question. Procedure, right now. Now, mark that point x on any line of your choice at a distance of, if it is a horizontal distance, tell x. If it is a vertical distance, tell y, just to understand. See, suppose you want to mark this way, call small x. See, small x. X is x only. Or if the point is this way, you call small y. If the point is this way, don't call point as y. Let it be x only. This x is not your analytical geometry, x, y, y axis. Unknown, see, that's why, see, I am making this way. X. Now see, in the procedure right here. Now you have to locate that point. You locate that point along any line at a distance of, if you are marking horizontal, x, small x distance, instead of marking vertical distance, small y distance, from any reference point. Class, one important concept. If the, see, I will tell you little later in the next class. Now right. If the resultant, see, I will tell only once. If the resultant is inclined, then it will cut each and every horizontal line and each and every vertical line. It will cut somewhere. But remember, sometimes, rarely, resultant will be purely vertical. If make a note, if resultant is purely vertical, it will not cut vertical line, it will cut only horizontal line. If the resultant is purely horizontal, it will cut only vertical line. Therefore, that point x you can take on any line, either on AB or on BC or on CD or DA, AB x from A or x from B, DC x from D or x from D, BC say y from B or y from C, AB either y from A or y from B. Because why? Because our resultant is inclined. An inclined line will cut each and every horizontal line and each and every vertical line. Why, I will tell you later. But by chance, if resultant is purely vertical, see, purely vertical, then it will cut only horizontal line. If you take here, you cannot take on this line. Or if resultant is purely horizontal, it will cut only vertical line. It will not cut horizontal line. Now write here, class. Write in the procedure also. Notes, more sketches. See, in the notes you can see more sketches. Now write in the class. In our present question, resultant is inclined. He guaranteed that if resultant is inclined, it will cut each and every line, horizontal line, vertical line. Now see the question paper. Sometime in exam question paper, they will ask you, locate it with respect to A. Then you can, from A you have take distance. From A you can cut either AB line or AD line. Sometimes they will tell, locate it with respect to A on AB line. Yes, then you have to cut it on AB line at X from A. Or sometimes they will tell, locate it on AD line with respect to A. Then from A you have to take on here. Or if they ask you, locate it on DC line with respect to C point, means your point should be taken here, say X from C. This all I will explain it later. Okay, right now, in right here, in right class, furthermore, in this question, nothing told. They simply told, find the resultant completely, which like any line of your choice. They are not bothered. They will tell you, find the resultant completely. That's all. Don't ask me which reference. You take whatever you want. Therefore, since no data given, we will right here in the class. You are right. Since no data given for this question, now we will locate the resultant what on AB line with respect to point A. So let us locate that point X on AB line. Why? Nothing told. See, let us locate that point X on AB line. Okay. Let line of action of resultant cut AB line at X. Where? See, A here, B here. Some point X. We don't know where. It can be beyond B also. It can be left side also. Don't worry about those things all. It can be any side. Cut it here at X from A. X from A. Suppose same question they ask you, locate on AB line with respect to B, means take X from B. This all I will tell you. This question I am solving more than 4-5 times now. But every time, my guarantee, answer will be same. Final answer will be same. Okay. That. Let the line of action of resultant cut AB line at a point, unknown point X, at X from A as shown. Very important. Decide correctly X from where? X from A, the shining point, X from A. Which side? We are taking right side, right here. You should write here. We are considering the point X on AB line at a distance of small x from A to right of A. That's very, very important. Right of A. Why? Because sign problem later. Our assumption is that the point is at here, from A, it is to right side. We do not know where. Suppose you take B, you have to mark this way, left side. Okay, leave it now. Now you have to get X. One more step. Through that point, mark the resultant. Okay. Angle not required. Now we are going to take moment about the point A. When you take moment about the point A, resultant is inclined, you require perpendicular distance. For that, you can save some time. In the sketch, you mark A dotted line, but instead of marking R, through the point X, enter those, which one? Enter those X and Y component. See, red color. Now suddenly, these two become red color, because these are properties of what? Resultant. It is 300. Sigma Y is 300. Oh, see, interchange. 300, this is 400. Okay. So, one more note you are right. Through that point X, dotted line mark resultant. Don't enter resultant 500 Newton, because if you mark 500, you require perpendicular distance here. So, what you do? Where at the through that point X, you consider the component. Easy for moment. So, or as if what? You are resolving the resultant. So, we got sigma fx left side upward. Enter this answer. Okay, now, this portion I am removing. I am getting the value of x now. See, this sketch I am not rubbing. This all I am removing. Okay, I will do it here only. Why unnecessary? Rubbing. Okay. Now see, I'll remove here. Yes, okay. I'll continue so that directly. Now you require x. See. Now see, to get x, to get that small x, to get that small x. That is, what you do is apply Varignon's theorem. Respect to Varignon. First time you are applying color. Apply Varignon's theorem. Varignon's theorem. Right. In the procedure, right, to locate that point x or to get the distance x or y later sometimes, apply Varignon's theorem. First, decide about which point you are going to take moment. See, from which point you took x, moment should be taken about the same point. Our x distance is from A. Therefore, most important point is A. See, that is here. Mark here. Mark here and also mark here. Red color. Consider moment about A. Moment about A. Why A? I told you. From which point you took x, same point you have to consider. Okay, now write the theorem once. Next time I won't write. See. Then the statement is what? Algebraic sum of moments of given force system about any point. About which point now? Now you should take moment about A. About A, this is LHS, equal to moment of resultant force. Remember, about the same point. About, now you have to take A. About A. If you write B here, B. Go for a sign convention. Either clockwise positive or anti-clockwise positive. Usually in the class, we will take clockwise positive. Your choice. Remember, this sign has nothing to do with the answer. This all I will explain for you. Some sign required. You can take anti-clockwise positive also. We will take clockwise positive. Now start. Left hand side. Now I should not explain because how to find moment I thoroughly explained. Couple I will tell you later. So start. Moment about A. Start from here. 150 into 360. Clockwise. Sorry, not explaining. Because why? One class. How much I explained moment calculation. So clockwise 150 into 360. Then 400 into 0 plus 400 into 0. Then come here. 100 into 360 anti-clockwise minus 100 into 360 plus 140 into 450. I will not explain. This I so thoroughly explained earlier. One class, see, master question. How much time I took? 8-9 point I took. If you are not studying properly from my old classes, don't continue my class. Okay. Or then 250 into 0. Then 200 into 450 minus anti-clockwise minus 200 into 450. Next, moment about this point, 700 into 0, actually not required, right? Into 0, also 160 into 0. But be careful, force system, two couples are there. Remember, little later I will tell you, when you want to moment about any point, if couples are there, for a couple, you should not multiply by distance. Simply write the couples here. Clockwise plus 75,000. No into. Sir, they told 195. They told 195 just to confuse you. This for force into distance. For a couple, directly couple. Clockwise means plus Anti-clockwise minus into is not there. So just plus 75,000. What about this one? Hey, get out. Minus 15,000. Minus 15,000 over equal to right hand side. See here. Moment about this point. Remember, clockwise positive sigma fx 400. See that I use red color. 400. That is your sigma fx into 0. Why? See? 0. Then see here. Minus 300, which is 300 sigma fy into your numerical value of x. Therefore, now solve it. You get the value of x unit in millimeter, and remember, write the value of x with sign. Very, 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 very important. Make a note here. Write it with sign. Otherwise, gone case. Okay, I'll calculate now. I'm not done. 150 into 360 minus 100 into 360 plus 140 into 450, then minus 200 into 450, that's all, plus 75,000 minus 15,000 divided by 300 plus 170, it is coming minus 170 millimeter. Minus, see, answer is coming minus how much? 170 millimeter. Decimal is not coming. I check once again now. I do not want wrong answer. Yes, minus 170 millimeter over. Yes, we got the answer, minus 170 over. Now, last step, I will write here, but I want to rub everything now. Next time onwards, this way all statement I will not give. I will tell where ignored, A, etc., etc., clockwise positive. That's all. Or some other question. Where ignored, D, clockwise positive. I won't waste time every time writing. So this question, what I wrote, those who are serious, you should write for each and every question. That is that is the duty of a person who is interested in studying everything. Okay, now I'll go to result for this one now. Last step. Okay, I repeat here. Here only right now. Wait. Now, conclusion. See, I am stopping this class today. Next class, I am extending the same question. What I will do? See, I will take x from B. Then I will take x on this plane. Then at A for AB. Then on this plane. From whichever reference point you take, along whichever line you consider, finally, everybody in the world should get same line of action. Okay, now, one important note. But I will not till next time. We considered point x at point x, where distance? Point x at small x from A. Small x from A. From the point A. Okay. And A means what? That is to which side? Right of A. See here. We took the point x from A. See the arrow mark here? To right of A. Actually, examination, you need not write. But we got negative sign for x. That is, we got x equal to minus 170 millimeter. That means that point X is not to right of A, not to right of A. Why negative A? Instead, that X is to left of A at what distance? Now you should not write minus. See, we took right of A, X came negative, left of A at 170 mm from A. If you write minus 170, it becomes nonsense. Why? We took right of A, X. X came negative means, oh, it is not that side, it is left side. Right? Oh, that is line of action of resultant lies outside the given figure. Okay, no problem. Okay, now last step now for today's class. Everything clear? Therefore, right here, closing answer. Closing. Next time I'll extend same question once again. Therefore, resultant force for given coplanar force system is as shown here, as shown below or right side anything. Okay, as shown. I'll mark it here. See, mark that original ABCD. See, this sketch will remain next time also. Okay, out of scale. Okay, this is the point A. This is B. We took the point X to right of A. Next is so from A, don't go right side. See, first of all, remember this is how much? This is 450. 450. Okay, now we took the point X to right of A. Negative came. How much? 170. So 450 half is 220. See, some respect to mathematics. From A, that point is now no X also. This is the point. So this passes how resultant is how this way. See, now write the answer. Resultant equal to 500 Newton with the X makes an angle of 36.87 degrees and line of action of resultant cuts the AB line on the left side by 170 millimeter is the final answer. Final answer. This question I may continue for 2 more classes for concept building. Next class, see what I am doing. Next class, I will take X from B. What will happen? Then I will take on the AD line what will happen. See, you will get this point. Then I will take this line. Then see, you will get some point here. That all I will explain to you. You first study, go through today's class. I have done systematically. Some will tell very slow. Yes, very slow for your benefit. You would have done faster. Shall I do faster? Show the talent? No, not talent. Show my speed. I can get all this within half minute or 1 minute. This I don't require all this concept. By looking at the sketch only, I can make out result and goes where. So, but teaching point of view, I told everything systematically. First, you thoroughly go through this question, understand, and then continue next class. A, B, C, D. Okay, C, D. Okay.